Hey, everybody, and welcome to yet another episode of Life's a Breach, the streaming series where we have interesting conversations about cloud security and cloud security with interesting folks. Today is going to be another fantastic discussion. We're talking about IaC, or infrastructure as code. Now, you hear this one a lot out there. In fact, it's so popular that now people are using as code in a lot of different places. So, to help cut through some of the hype, to look at the benefits, to bat away some of those misconceptions, I'm joined today by Charles Kim. Charles is a product manager here at Lacework with a deep, deep knowledge of the IaC space. He's been thinking about this problem a lot, and today we're going to tap into a tiny bit of that knowledge. Charles, thanks for joining me today.
Thanks, Mark, for having me.
Yeah, this is going to be really, really good. And before we dive into the conversation, as a reminder to the audience, we are live here on LinkedIn. So if you have comments, if you have questions, jump in the chat and we will integrate them into the conversation as we go. That's what makes this show and this series really special, is when you get involved. So don't be shy. And with that, Charles, let's start off with hopefully a simple one, though I've learned better on this series that there are no simple questions. There is always going to be a bunch of nuance and extra pieces that we haven't thought about. But what is, like, conceptually, what is IaC, or infrastructure as code?
Yeah, and you saw me biting my tongue a little bit. I was like, oh, how deep should I go here? So I think at a very high level, let's kind of describe what was before IaC, right? Like if you think about how infrastructure was built in the cloud, you had a console and you had APIs and you had a CLI, and you can interact with one of those three in several ways to construct your cloud infrastructure. But what infrastructure as code kind of creates as a paradigm is managing and provisioning that infrastructure through using code. Now, what that code and what that looks like is kind of up for debate right now, right? But if I'm going to use the analogy here, it's like IaC is like the blueprint of the house. It's clearly documented on how the house should be built. Now, the problem here, and where we're seeing kind of like where this drifts in the conversation of what language works and which one doesn't, is how should that blueprint be defined, right? You can have what we call the IKEA model, right? It lays out every single step about here's the bolt, here's the leg, screw it into the table, you have a desk, right? Or, and that's called the imperative approach, right? Like you have to be very, very, very clear on what CRUD operations you want to construct your infrastructure. And then you have the declarative approach, which is here's a desk, these are all the components, go figure it out, right? And one of the interesting things about the declarative approach is that it abstracts the CRUD operations on behalf of the individual who needs to build the infrastructure as code. And it makes the overhead of the skill sets needed to build that off to the language provider, right? To the framework, right? So examples of imperative, right? The IKEA manual is like Ansible playbooks, right? You can build infrastructure as code using Ansible playbooks. And then there's the declarative approach, which is like Terraform and CloudFormation, which say, I want an EC2, go figure out how to make it happen, right? And you describe the final state, and then it will figure out what to do to get to that to achieve that final state.
Okay. There was a lot of great stuff in there. And just for the audience, CRUD is create, read, update, and delete a series of operations, sort of the standard, just in case. I think most of our audience is beyond that technical level, but we always like to make sure. But one of the analogies you used kind of made me chuckle, but also cringe a little bit. So, I'll ask you right off the bat, is if one of these approaches is better than the other, because when you said IKEA, I just imagine the amount of frustration I have of getting to step 20 and inevitably realizing that I installed the Flarfenugan backwards instead of the proper way and having to go back. And so is that the case with imperative, or is imperative or declarative, is one better than the other, or is it just dependent on the situation?
I think it absolutely depends on the situation, right? And like kind of just going into this, and this is where like I think it's important not to be overly religious on one framework over the other, because there has been some benefits on both, right? Like if you think about imperative, it's amazing for thinking about migration efforts, right? You have a database instance, you need to move it to a new database instance. I can use an imperative language to kind of construct the steps in which to do that, and then I'll have fallback mechanisms in the event that it fails, right?
Okay.
Declarative is, like with great power comes great responsibility. If I do it the wrong way, I can just completely destroy my original database, and all that information I needed or was important to the customer is gone, right? So that's incredibly like there's pros and cons to both, and I think it's just more important to say it really is going to depend on what it is you're trying to tackle, right? Yeah.
Yeah. So high level takeaway there is imperative, declarative. There's pros and cons to each. Don't religiously follow one or the other. Figure out what makes sense for your situation.
Yes.
Yeah. Okay. So with that, let me go into the next big question then. Is what I wanted to ask was, it's assumed that this is the way forward. Like everybody should be using IaC. It's the only thing to do. Why? What are the advantages to a team or an organization to adopting this approach of using infrastructure as code?
Yeah, so let's use a very simple like web infrastructure like as an example. So you need to build a three-tier web architecture in cloud, and you need to spin up EC2 instances, some subnet groups, some routing tables, or some security groups, some subnets, some routing. You need the VPC. You need all these components, right? And then you need to involve all these different teams that own some of these different things separately, and say, well, you need to build this, then this, then this, and that. And the main challenge with that is it's manual. There's a lot of interdependencies, and if those interdependencies fail, you could just have a disaster at your hands, right? So speed and cost reduction are actually one of the big ones. Is that by defining the infrastructure as code, you have a single source of truth of how it should be defined. You click, for example, Terraform apply, and you can hopefully walk away and drink your coffee, right? So that offloads a lot of effort from your networking teams. Yeah, exactly, right? Your security teams, your developers, your database teams. It offloads so much off of their plate, right? And it lets them focus on their core needs and the core asks from those projects, right? The other thing here is scalability and standardization. In that same example, I might need to start scaling that web architecture. So I might need more servers. So in order to do that, I just need to say, well, let me just copy paste that EC2 instance code that I use and just keep making more of those. And then now I've scaled, quote unquote, right? That's in theory. Obviously, there's so much more to that. But one of the beauties of standardization with code is that now everyone's looking at the same source of truth, not some other variation of source of truth. And what I mean by that is that a lot of times documentations get stale very quickly with the cloud, right? At any given hour, your infrastructure has gone stale and has changed drastically than what it did the previous day or even the previous minute, right? And so as a result, like how can you maintain order in the chaos, or at least how can everyone understand what that chaos looks like at that point in time? And so having everything being defined just in code makes standardization and makes everyone understand the same source of truth, right? There's nothing up for debate. The last thing, and I'll just speak really quickly, is disaster recovery, right? You spun up that web service in USE's 2. It's Christmas time. You're supposed to have dinner with your family, and there's a problem, right? And the beauty of infrastructure as code is that, like in theory, you just go to the code and you go to the particular place for your AWS infrastructure as code and say, for the region, I'm going to change it from US East 2 to US West 1, and I can walk away, right? Again, in theory, but that's the beauty of what it empowers entire teams, DevOps, operations, security teams to kind of think about is how quick can you recover from an event?
Yeah, and so there was a lot in that, and that was great because it highlighted those big advantages. Let's tackle disaster recovery first for a second, because I think the key takeaway there was that it helps, but it doesn't solve because it's complicated disaster recovery. But I think that ties to that idea of standardization you mentioned as one of those huge advantages, to be able to actually point to something that is accurate as far as saying, like, this is what our infrastructure looks like, Charles. Based on that, let's have a discussion, as opposed to, I think it looks like this and you think it looks like this, and we're not talking the same thing at all. And I mean, even if you had no other benefits, that alone, to be able to enable that discussion across the teams about talking about the same thing, that's massive, because I've seen that conversation go both ways, go where the teams are talking about completely different things, and some person off in the corner or some person who's no longer even with the company knows some weird little quirk of how it was built and nobody else knows it. But now that weird quirk is documented. It's in the code, and that's the truth because that's literally what was run. But of course, I think we've all been around long enough to know that it's never that easy. It's never that simple that it's just like, yay, there's all these advantages and we win. When, like you said, we can just walk away. I would love to be able to walk away after running a command, but I don't have that much bravery. So there's got to be downsides here. What do you think the biggest disadvantages of this approach are? Like, where are the challenges going to be?
Yeah, and I think the challenges are very, very clear, but and there's actually ways to solve them. So I'll actually kind of caveat and say, well, these are the problems, but you can actually solve them. And here's a couple examples of how, right? But one of the most common ones is that you're introducing yet another language, right? And you know what YAML stands, and there's pros and like there's very divided community between YAML, right?
Yeah.
So introducing yet another language is going to be an interesting problem because it's not just a language in itself, it's also how do you have everyone aligned to it, and also like are you going to be religious to say I will only use Terraform for everything I do?
Hmm.
What if that doesn't work for other parts of the team? What if they are managing their infrastructure as code using Ansible today? And asking them to migrate to Terraform is like asking all their projects to be delayed by 3 months as they start learning a new language and start refactoring all their code, right? So it's still yet another language, still yet another code. And a lot of organizations are already doing infrastructure as code to some degree. It's just a
Hmm.
question of can you standardize it all, right? So it's still yet another convention that you're kind of asking everyone to follow. You can kind of solve this problem in several ways, right? Like one of the things we've seen, especially with like larger enterprises, is the idea of abstracting the infrastructure as code itself, right? If you recognize that very commonly across all your development teams, they want to instantiate an RDS database, and they don't really care about all the different configuration parameters of the RDS. They just need a namespace. They want it to tie to a certain password in their hash in their vaults, right?
Yeah.
Or some of the other much more important parameters. Then you can kind of templatize this, right? And then you can create that template, and you can say, and you can provide self-service portals for developers to say, do you want to spin up an RDS instance? Click here. Boom. There's a Terraform template. It applies and it instantiates it in the infrastructure. You still get the benefits of infrastructure as code, whereas it like maintains it all in some sort of code format, and it's all maintained in a repo. Actually, I'll get into the repo part in a bit. But that's one way to solve the problem.
Okay.
The next thing is traceability. So you mentioned that particular example where there's that one person in the corner who did something very particular, and no one had any idea, and everyone's kind of pointing at each other like that Spider-Man meme, like it's you, it's you, it's you, right? And the reality is that that is the challenge with infrastructure as code is like it is very loose such that any individual developer can start adopting it. But
Hmm.
then how do you start thinking about governance? How do you start thinking about what, who does what with the infrastructure as code? And also, even in the infrastructure as code, what is a source of truth? There could be a million different infrastructure as code templates used to define the same resource. Which one is being currently used to deploy and manage it, right? And so there's a concept called GitOps. It's becoming much more common now, which is you use GitHub or Git as your source of truth, right?
Hmm.
You might want to define a new variation of that S3 bucket that someone else deployed. You create a separate branch off of your GitHub repo. You define those parameters, and then you merge it into your main branch, and you say, I want a new S3 bucket. This is how I want it. And someone will audit it and say, well, is this okay? Maybe we should be using an existing one. Or actually, you know what? I already had that in another template in another folder that this developer may not have seen. So maybe there's a way to reconcile these things. And so using GitHub as an ideal way to manage that source of truth is really helpful. So for those that are unfamiliar to the phrase, look up GitOps, and it's just a way of using Git as a way to operationalize your infrastructure as code.
Okay.
Oh, go ahead.
Keep going. No, no, keep going.
Sorry, I could keep going on and on, but there's also aspects here about RBAC and kind of ownership of different components of the code, right? You have database infrastructure as code, you have network infrastructure as code, you have server infrastructure as code, you have other layers here, right? Who owns them? How do they own it? And then how do you make sure that someone from the database team isn't just accidentally manipulating the routing table and allowing traffic from all from the entire internet to access that database, right? So in order to do that, you can solve this in several ways, right? Some frameworks already inherently have RBAC, like Lumi. Some
Mhm.
others have management services like Terraform Cloud and Terraform Enterprise that help you maintain RBAC by defining what's called workspaces. So there's many ways to solve that problem. And then the last and final one, and this, this will make some people chuckle, but like feature lag, right? Like you have this new service you want to use in AWS, just launched it in reInvent a couple months ago, right? As an example, and you're using your favorite infrastructure as code provider, and it turns out there is no code available today to define that. And if you use an example like Terraform, Terraform is both managed by the vendor HashiCorp and also
Mhm.
by the open source community. So someone somewhere needs to build that code to define that provider for that new service you want to use. It could be you, it could be someone else, but there's usually a lag in between that service you want to use that's brand new versus what that language provider for infrastructure as code can actually give you for that. Even today, for example, with Terraform, not all resources support tags. So how do you manage that chaos, right?
Yeah.
Yeah, that's basically it.
That's basically it. Just that. That's it.
Yeah.
And no, I mean those are great points. And I mean, just on that feature lag, because that was the last one you made in that section. That's a problem even for the cloud providers. AWS famously has always struggled to get the latest and greatest into cloud formation on day one, and they're getting better at it. But for years, they would announce something and it would take a couple weeks to get into cloud formation. You're like, but I want it now. So one thing that I kind of, as you were pointing out all those challenges, the thing that kind of came to mind was that you, as a team adopting this, need to weigh those challenges versus the benefits you're going to get,
Mm-hmm.
because the things that you talked about, as far as like using it as governance, worried about role-based access control or RBAC, and what repo where, as sort of the code shareability. These are additional challenges that are brought on by adopting this tool, never mind the fact that you need to figure out which tool. That needs to give you the overall benefits. So those benefits of standardization, of having that source of truth, being able to have common discussions, need to outweigh it. Now, in my experience, most of the time they do, because those are really big advantages. But let's dive in for a second into that code one, because I thought that was really interesting when you said that now there's starting to be sort of this layer of abstraction on top of the IaC. And again, not to keep picking on AWS, but they launched a product, I think a year and a half ago, called the CDK, or the Cloud Development Kit. And when
Mm-hmm.
it came out, I didn't understand the value. But you just explained it perfectly. And essentially, the CDK allows developers in Python or Java, I believe it is, a custom domain-specific language to describe the cloud infrastructure they want, and then it spits out CloudFormation underneath. But it solves that language problem, is that now if you go, oh, we're a Python shop, great, just stick in Python. You don't need to learn Terraform or CloudFormation or anything else. You're good there. But that has the same challenges of, you look at any shop, like I look internally here at Lacework, and name a language, we're using it in production somewhere. Right? Like, and I mean, that's fine. Every language has advantages. And I imagine that's the same thing. Maybe you can comment on that in the IaC space, given that there's all these different solutions. I've got to imagine there's pros and cons to each of them depending on what you're trying to tackle.
Yeah, absolutely. And this is where I keep cautioning like the audience is like, don't get overly religious on one or the other, because it will at some point, you will stretch its boundaries, right? And that's okay. That's
Mhm.
there are some constraints because that's the layer of abstraction that they've intended to, right? So like a classic example is Kubernetes versus managing the cloud native infrastructure, right?
Yep.
A lot of times you actually need an imperative approach with Kubernetes because it manages its own declarative nature, but actually how do you deploy your Kubernetes clusters and how you do that on a regular basis? You actually want to maintain your CRUD operations because, well, do you really want to just leave it up to, the demo gods to make sure it doesn't just magically destroy everything you have? Like that's,
Mhm.
I don't know, right? And then, so there's an interesting challenge there, right? The other thing, as you're calling it out, is like getting infrastructure as code as close to the native workflows is really important. Like CDK and Pulumi has been a great example of those, right? Pulumi is effectively just like the multi-cloud equivalent of CDK.
Mhm.
And as you're calling it out, like sometimes you need to lean into the cloud specific providers infrastructure as code because that's where you're going to get those benefits, right? Like
Yeah.
I think 2 or 3 months ago, AWS released the closed account API for AWS org.
Yes.
Okay, so when can I use that in Terraform, right? That's the number one, that's the question. And then, maybe you actually lean in and just start using AWS CDK or CloudFormation to manage that. So that's the honest answer. It's much easier to just not get too hung up on each particular language and their caveats and just say, you know what, for some use cases, I'll use CloudFormation. I might maintain it in one mono repo, which in itself is its own problem, right? Versus maintaining it in multiple repos, but I don't think I have enough time to kind of discuss that.
Fair, and yeah, and I think the important thing, and that ties to your comments around GitOps as well, is that because this is code, we have all the same challenges as managing our normal code base, right? So the
Yes.
question of how do you handle branches? Do you go mono repo, multi repo? Like all of the things we discuss as computer scientists and technologists, those things apply here now because we've abstracted it as code, and so now we have to deal with the code. So yeah, we'll pause that. Because we can do another show on that one. But I want to tackle in what you'd mentioned around RBAC, so role-based access control, as well as governance, because I think that's really interesting in that the cloud has some really, whether it's AWS, Google Cloud, or Azure, they've got a really advanced and powerful identity and access management system built into them. And the interesting thing is in your comments was that now that you're adding this ability from your infrastructure as code to build that infrastructure, you have this challenge of, okay, whoever's executing that or whatever is executing that needs permissions to build it. And quite often what I see is that teams will grant the system that is building their infrastructure almost admin rights, if not full admin rights, which means then any user of that, now you need to shift the role-based access control to that build tool, to the infrastructure as code tool, because you don't want me to be able to blow away what you've built or for you to overwrite this and that. And so I think that's really interesting. And what do you see in your experience dealing with teams who are rolling this out in that sort of disconnect of like, well, in AWS, the builds, the IaC system can do anything, but I don't want you to be able to do anything. I need to rein you in. How do
Yeah.
they balance that, and are they aware that this is a governance challenge?
I think it's a governance and also it's a security challenge. And I'll kind of like, they're two separate problems, but like the
Mhm.
governance challenge is interesting because it's like, you give a build system basically admin access to do anything and everything you want, which, up until now, without infrastructure as code, that's pretty much how a lot of people that had to follow the ClickOps model, meaning you had to go to the console, you had to deploy something, kind of
Mhm.
already had to do, right? Now, the interesting thing is that the RBAC problem was moved towards the cloud native IAM controls saying, you, Mark, who want to deploy an RDS instance, should not be able to deploy everything else that this three-tier web architecture needs, right?
Mhm.
Maybe that's the scope of what your permissions are. But then when you start moving it to the build system and it basically has the keys to the castle, then you also move the problem to and the onus of doing what's right for both the organization and the service and security requirements over to effectively the authors of the code, right? Whether you call it dev or DevOps. And it's an interesting problem because when you think about how how many teams think about deploying a project, you actually rely on pre-existing tutorials, right? It's very fun and easy to find a GitHub repo that has an example of what you kind of want to build,
Mhm.
copy pasting that code into your own repo, and then playing around with it in your own dev environment and saying, well, it's functional. Let's start deploying this into production, right? And a lot of times security can get overlooked. It's not that it's intentionally ignored. It can be overlooked because the security group was defined in a subdirectory that's part of a different module that's referenced in the main.tf file, and that security group exposes all traffic to an EC2 instance that the developer didn't realize is actually public facing. And now you have this problem, this dilemma, right? It's so easy to overlook it. It's not that anyone's intentionally, hopefully,
Yeah. Yeah.
intentionally malicious in what they're
It's a
doing.
mistake.
It's just an honest mistake, just like bugs
Mhm.
in code, right? But just like bugs in code, we need to start thinking about using a test-driven development effort, right? TDD for short.
Mhm.
And the idea is, if you know that an honest mistake can happen, can you catch those honest mistakes early in the feedback loop so that the individuals, the authors, can correct those mistakes relatively quickly without actually impacting their workflow at all, right? And so I think security in the code is more and more important because kind of the onus of doing deploying a secure infrastructure is now moving towards the authors of the infrastructure as code.
So let's dive in there. What are the security advantages? Like if we just put a security lens on this, if a team has adopted IaC and they've tackled all the other stuff that we've talked about already, and they've got a handle on it reasonably, are there security advantages or disadvantages to using IaC? Like what can we improve our security posture by using IaC?
Yeah, so this is like one of the potential misconceptions is that because it's defined in infrastructure as code, the quality of, or not the quality, but the security posture will naturally go up, right? Because
Mhm.
your blast radius is constrained to maybe I have one security group and it's used across all my EC2 instances, as an example. So therefore, I just need to manipulate that one security group, and now I've handled, a lot of the misconfigurations, right? The interesting challenge is still like, does the authors actually recognize that those are misconfigurations to begin with, right? So it's like it's kind of like a chicken and egg problem. It's like, well, are they aware that those are the problems? Do the authors recognize it and remediate them already naturally? Or, is there a gap in understanding that that tutorial that you copy pasted from GitHub was actually just a tutorial and was never meant to be productized, for any good reason, right? So that's the harsh reality. And I think, it's this is not a question about who's to blame. It's just a question of like, can everyone rise to a certain minimum standard of this is how you address those problems, right? Just like with bugs, unit testing helps any developer of any experience level to understand how to rewrite or change the code. IaC security will help everyone standardize to a base minimum of this is the right hygiene
Mhm.
or right level of security awareness you should have, right?
Okay. And does that mean, like, if you take that to the next step, does that mean with infrastructure as code, we can start looking at sort of what it's about to build and set in almost like a linter kind of thing of setting like, no, no, like, don't do that. That's bad.
Yeah,
And let's
yeah.
not
Stop it.
ever let that hit production.
Yes. Yeah. And then what's great is that like when you start thinking about TDD or test driven development, you can start baking it as part of the build process, right?
Mhm.
As a developer who wants to add that extra EC2 instance, it's public facing, it's unencrypted, like it uses a data store that's unencrypted at rest and exposes SSH and telnet traffic. Is that the right thing to do?
Oh,
And during the pull request, can you let that developer know, hey, I think you might run into some problems down the road, and this is how you should actually like this is actually how you can avoid them in the future. And a lot of times it's actually kind of well received as long as it's well understood what are the things that need to be changed, right?
yeah, well, and that is tackling the number one problem that security has is that as a community, we generally just say no with no explanation. Whereas if you can do it in the check-in, I checked in some code and like, hey, by the way, Mark, this, is going to actually expose this asset to the internet unauthenticated. You're like, oh, wait, I didn't want that. Because most of the time it is just a mistake or a misconfiguration. That in the moment sort of feedback loop is hugely beneficial. And because nobody wants to write crappy code. Nobody sits up and goes like, okay, I want to build something that's horrible. Let's go. At least in your daily work. So I think that's super powerful. But there was a word you mentioned a couple of times, Charles, that I'd like to dive in on is misconceptions. So you've been around this space, you've thought deeply about it, we had tons of conversations with organizations around the world. What do you keep running into as sort of the common misconceptions about IAC?
Yeah, I think one of the biggest misconceptions is that it's fail proof, and that if you have a handful of developers starting to adopt infrastructure as code, it solves all your problems. It doesn't really, right? Like it introduces a new governance challenge, and if you can stay ahead of that problem, then it's really not that hard, right? And the other problem here is a misconception around that it's not constrained to other code challenges, right? Like keeping your code dry is a number one problem, right? Like as for many organizations, you end up finding out that many developers are writing the same code, defining the same assets with the same configurations. How can you keep it dry, and how can they all recognize that there's some level of consistency that can be done?
Mhm.
Yeah, but that's a big one. And then the other thing is that multi-cloud IaC frameworks, yes, you can use them to deploy across multiple clouds, but it doesn't mean the code can just be transplanted to define one infrastructure in AWS to Azure to GCP. It's not like, oh, let me just change the provider of my infrastructure to one of these,
Mhm.
right? It's not like that. And you still have to refactor that code. You still have to manage it. And they each have their own constraints around what is considered IAM, what is considered networking, what is considered all of these other
Mhm.
concepts across each cloud provider. So multi-cloud IaC frameworks are not multi-cloud in the abstraction. It is a framework that I can use across each of these cloud providers. I think that's the best way to describe it.
Yeah, so and I think that's a good across cloud versus multi-cloud, meaning that the objects in the cloud are supported. It's supported as a target to go to AWS, to go to Google, to go to Azure. But even something as simple, so IAM, maybe not everybody's familiar with the nuances between the cloud providers, but something as simple as compute, right? Give me a virtual machine or an instance. The way those are designed in each of the three providers, the sizes don't line up. So if you say, give me a memory optimized XL in AWS, there's not a direct equivalent in the others. You can get the same things, but it's not the same. Like, give me this label. It's not A1, A2, A3. It's a fundamentally different thing to get the same result. So I think that one I hit quite often when people think multi-cloud is going to be so much easier, and IaC is the solution to multi-cloud. And it's not that there's not advantages to being in more than one cloud provider. I think it's, and you're chuckling because I think you've had the same conversations. It's the casualness that people go like, oh yeah, no, we're going to go cross multiple clouds. And you're just like, okay, I'll talk to you in a couple of weeks and see if you're still happy and hand wavy about it, because good luck. So be respectful of time here, Charles. This has been fantastic, but there is one thing we always try to do when we're winding down these discussions is sort of give the audience something practical, something to focus on, because we've covered a ton here, and I think it's really helped set the stage so people have a better understanding. You've broken down some of these misconceptions. They've got a clearer idea of what they can actually get out of IaC, what to watch out for. But is there one thing that you would say, like, this is the key to your taking that first step successfully? Like, what is the one thing above all else that you think, people who are just starting along this path should be aware of or should focus on?
Yeah, I think um, understanding what infrastructure as code really means is, I think, the number one ask, because a lot of times you kind of see, the high level, like I write this code and now I've instantiated my entire production environment, right? It sounds very magical and hand wavy, but there's so much to that. And the reason that becomes so interesting is because then there's this like unintentional divide between dev and ops potentially with infrastructure as code, where sometimes you don't want to touch the code because you just don't know what's going to happen. Like, oh no, like am I gonna be the person that creates the outage? Am I gonna have to get
Mhm.
in a meeting with leadership about this, right? So like there's it needs to be very approachable, and like encourage their approachability to understand these concepts very thoroughly is, I think, the number one ask, because everything else kind of solves itself over time once you recognize the caveats.
Okay. And I think that's really good advice. So, some lunch and learn, some open discussions before you start down the path, because I think what ties into that is a lot of the time people assume that they know, and like, oh, I know what IAC is and I'm going to be, working on it this way. But if you and I were working on it, my knowledge level's here, yours is off the charts. What you know and understand is completely different, and we're not operating on the same plane, right? And so having those discussions, getting it out and saying, okay, this is what we're intending to do. This is how we think we're going to approach it. That's fantastic advice, Charles. With that, thank you very much for jumping on the stream today. We're going to have you back on because I got a ton of notes of stuff that we can follow up on, and this has been so valuable for me, but also for the audience, which is probably more important. And so thanks for jumping on.
Likewise, it was a pleasure.
Thank you. And thanks to everybody for tuning in today. As always, we appreciate your comments. We are monitoring the post. These live streams pop up like a post on our LinkedIn page. We will keep continuing to monitor the comments for the discussions. If you have ideas about topics that you want us to tackle next, or particular folks that you'd like to see here on the stream, get in the comments, let us know. The show only gets better the more interaction and engagement we get. Remember to follow the Lacework LinkedIn live page to get notified the next time we go live, and we'll see you in the next one.